was that we'll be using a PIR. We'll be using a PIR which we are using currently for pedestrian tracking. Secondly, we wanted to use a time of flight sensor for tracking of vehicles, and basically our design implementation was that we want to make a system that is fully capable and only exists on a certain pole. It is wireless.
What is the problem in practice?
Smart street light solution. So the idea of the problem that we're trying to solve is that we feel that keeping the street lights on, irrespective of whether or not somebody is there on the street, is very inefficient and is power loss is caused. So we are selectively keeping it on. That is what our idea is. And then we're using currently for the sake of demonstration, we're using IR. We know the limitations of IR in terms of this application is that ambient light will affect it a lot from daylight to night light, and also the color of your car and the reflectance of it can also affect the safety of it. So we know the limitations of it, but for the sake of demonstration that is there. So we wanted it to be a box-like solution that can be strapped onto a existing street light. Won't require a lot of wiring. You just need to interfere with the power supply of it and give it parallel to this. So in this also, we were not able to source a solar panel ourselves. So for the sake of demonstration, there's a LDR. LDR, we have covered it. If we were to remove the LDR,
it would simulate the daytime situation, and none of the LEDs will turn on and off in the course of time. Even if we trigger any of the IR sensors here right now, none of the LEDs will blink on the other side of the road that we are transmitting through this wirelessly. So our idea was to create such an application which can be strapped onto the current system and does not take wiring, so that all the communication that takes place between the adjacent poles is wireless using the ESP-NOW protocol. So here to simulate the nighttime situation, we are using a tape to cover the LDR to simulate the nighttime conditions. Once we cover this LDR with the tape, we can now simulate it in such a way that it will perform in the night. So once we move a car, for example, let's consider this as a vehicle. These two sensors will take the time it took to cover the distance from this point to this point and will deduce a speed. According to the speed, the consecutive lights will turn on simultaneously, and once the vehicle has passed away, it will turn off consecutively one by one. Let me just show you.
Yes, that's it. The lights will turn on based on the speed of the vehicle. If the vehicle is moving slowly, I'll just show you. So this was the speed. If I move the vehicle very slowly, the vehicle is not moving very fast. So now
the LEDs will turn on slowly. For now, we have used LED to depict the street lights, as it would be a very hasty task to create such conditions like making a lamp and all. So we avoided that. As the vehicle was moving very slowly, we used the LEDs
since
to
the
depict
vehicle
the
is not moving very fast, we don't need further street lights to be turned on now.
Okay.
If we increase the speed, the street lights would turn on faster. Now the street lights should turn on faster. Yeah, the speed has increased. So based on the speed of the vehicle, we are like switching on the lights, and due to some traffic or something, if both the IR sensors are giving reading, then to avoid the redundancy, like both the sensors are giving one. So
we are using
the RASCAN to check the traffic. If it senses more number of cars, then all the LEDs would be turned on at once.
So as to avoid any mishaps and accidents on the road, we have decided that once we see a bulk amount of cars on the road, we are going to turn on all the street lights available to avoid accidents. And once the bulk situation is removed,
all
the
LEDs
will pop off normally
and
as
sensors would work again.
apart from this, when there is a bulk detection, we are also trying to implement a display. Yes, it is saying drive safe. Once it has detected the bulk presence of vehicle, it will display the drivers that there is traffic ahead, drive safely.
It means more than one IR sensor is giving a reading. That means there are more number of cars on the road. So we use the Raspberry to detect the number of cars. If the number of cars is like more number of cars on the road, we will turn on all the lights and we will print here that traffic light.
So for the wireless communication type, we are using ESP-NOW protocol, which the line of sight range is 500 meters, but in ideal condition we can consider it up to 200 meters, and it will use a mesh network topology. Even if one system fails, it can transmit the data to the another system. We propose a system of multiple ESP32s, but due to the software hardware limitations, we have performed it on 2 ESPs for now.
And our basic idea was
And how
to-
much cost will it go in and multiple?
If we are talking about one system, actually for scaling down the project, we are using this, different sensors. Now, it will depend upon the type of lidars that we are going to use. It also depends upon the length of the width of the road that we are going to read.
Also the distance
and also the
between the-
distance between the yes. So on and around, if we see, this model costs around 400 to 300 rupees of range. We are not going to shift to another model. So model is the fixed thing. Then solar panel, we can depending upon the power source and the battery and the charging condition. We also decided to give the generated solar energy back to the grid so that it can be used
the
somewhere
battery
else
is
when
fully
the batteries
charged.
are fully charged. So even if there is a grid failure or power failure, our street lights
you can
won't
see
go off.
when the battery is fully charged, battery also solar panel also gives the power back to the grid. So that's like
A plus point for
Plus
this
point
system.
for this system.
As we all know, there are renewable, so there is a great need of renewable sources around here. So if you are using a solar powered panel, it will charge the battery, and once the battery is sufficiently charged, it will give the power back to the grid.
And here, as you can see, we have connected like let's say 5 ESPs, and 5 ESPs are connected to a Raspberry Pi. So the Raspberry Pi is only connected to the last ESP through the USB. So we are using UART protocol to connect the Raspberry Pi and the USB. Whenever there is some redundant data, like you saw that both the sensors are giving some value, then only the last ESP will connect to the Raspberry Pi. It will say that there is some issue. You turn on your camera and see what's happening. And if there are more number of cars, it will turn on all the street lights. All the street lights of the ESP is connected to it.
So our proposed solution is that an individual box would contain a microcontroller for that is ESP32, a sensor which will track a vehicle, a sensor for pedestrian tracking, a solar panel, a battery, and a battery charging system
The
that will be
pedestrian
connected to the
tracking.
grid. So as a whole, this will be somewhat of a box-like situation that can be strapped onto an existing street lights that you don't need to run more wires to the conduit or make a new one or anything. And
there
the
won't
other
be,
kind.
more changes in the code. Just replace the LEDs with relay modules, and you can use these signals to control
the
the
existing.
street lights that are currently.
So our
used.
main goal was to not to add much of a hardware, just to add the microcontroller, like the box, as we said. The box would be connected to the existing power supply, and each boxes would talk to each other using ESP now. So there is no wiring in between. Only wiring part would be the last ESP would be connected to the Raspberry Pi.
As there will be less wires, there will be less maintenance, and also if one system fails, we have a failsafe that we can send this data to other ESPs also.
Yeah, because the ESPs are talking to each other. Here there are only 2. If we consider 5, each ESP is talking to each other using a mesh topology. So even if one street light fails, it can talk to the third street light and tell the Raspberry Pi that there is something wrong. You check, you turn on the camera and all that.
So it's like making minimum modification
Yes,
on the current
on the current
system,
system.
enhance the functionality of the system.